Welcome to the SimScale platform. In this short tutorial, we will provide an example on how to run solid mechanics simulations on SimScale. As an example, we will run a linear static stress analysis of a connecting rod. First, we create a new project and then switch to the mesh creator. Next, we will upload a CAD model of the application that we want to analyze, in this case, the connecting rod. The SimScale platform supports different CAD formats, such as STEP, IGES, and BREP. Also STL is supported. As soon as the upload is finished, we can directly interact with the model in 3D. We can zoom, rotate, and pick entities of the models as we would in a normal desktop application. Now the next step is to create a mesh based on this CAD model. So we hit the Create New Mesh button within the geometries. This automatically triggers a new entry in the tree on the meshes. Within this entry, we can now add a mesh operation that further specifies how the mesh shall be generated. The SimScale platform supports multiple mesh operations for both finite volume and finite element meshes. In this case, we will go with a fully automatic tetrahedralization of this connecting rod. As soon as we confirm the mesh operation, it is carried out in the cloud on the machine of our choice. The notification area in the lower left or the message boxes in the lower right always indicate what the system is currently doing. As soon as the mesh operation is completed, we can review the mesh. Here we can see that the fully automatic tetrahedralization operation takes care of all the details of the CAD model. The viewer provides more options to visualize the mesh. For a more detailed analysis of the mesh, you can review the event log. There you can see how many elements and how many nodes and what kind of elements have been generated throughout the mesh operation. Having reviewed the mesh, we can now set up the actual simulation within the simulation designer. Therefore, we create a new simulation and decide on the type of analysis that we want to run. In this case, as indicated in the beginning, we will run a simple static stress analysis of the connecting rod. The tree on the left always indicates the steps that are left to complete the analysis setup. So the next thing to do is to assign a mesh to this simulation. We are using the mesh that we've just created within the mesh creator. Next, we will define global properties of this simulation. Here we could assign a gravity to the simulation, but in this case we will just ignore it and go on. The next tree item is the material definition. In this case, we will add just one single material that we call steel. For the connecting rod, we will just go with a normal steel and leave it with the default values. Under this tree item, we could create multiple materials if our model would consist out of multiple solids. To assign the material to the actual solid, we click on Pick Volumes and assign it from the viewer to this material. The next step is to define the boundary conditions of this model. Let's go with a very simple setup. I'll create a new displacement boundary condition that I call fixed bearing. This boundary condition shall mean that the nodes are not allowed to move in any direction. So I'll fix all directions. Now let's see where we will apply this boundary condition. In this case, we will just go with these inner faces of the connecting rod. I'll select them. Let's switch to the surfaces view to have a better visualization. And then I'll click on Assign Selection from Viewer, which completes the definition of this boundary condition. Having defined a displacement boundary condition, we will next go back to Boundary Condition Overview and assign a force boundary condition. Again, let's keep it simple. I'll assign a simple pressure boundary condition and call it normal pressure. It allows the definition of a specified pressure value. Again, next, we have to decide on which faces this boundary condition shall be applied. So let's clear the selection and pick faces for this boundary condition. In this case, we will just use the inner faces of this part of the connecting rod. Again, clicking on Assign Selection from Viewer and saving completes the definition of the boundary condition. The next three items are already indicated in green. This means that they would be good to go for a simulation run. But for the sake of completeness, let's check on them. On the numerics, we can specify an equation solver. On the simulation control, we could choose the hardware that we want to use for this simulation run. Since we're currently in the basic plan, we just have one computing core. Under information, there is general information on this simulation. To start the simulation, we create a run for it. The concept of a run basically means that we create a snapshot of the current simulation specification. The properties of a run cannot be changed anymore. So in a later review, we always have access to all the details of one simulation run. So let's hit the confirm button. And in the job status box in the lower left, you can always review the progress of your current job. Let's speed this up a little bit. And you get notified via email as soon as your job is finished, and now we have access to its results. Now we could either download the results and post-process them locally or use the integrated post-processing environment. Here we click on the solution fields to get a 3D visualization of them. Here we can see the displacement field with the magnitude as the component. Again, we can interact with it in 3D and review the results. The integrated post-processing environment provides tools and operations to further analyze the results. Here we can see a visualization of the von Mises stress. Thanks a lot for watching this short tutorial and have fun starting your own project on the SimScale platform.